is the entire schedule for the whole year, whole semester. So today, what we're going to deal with is conduction, and then next week we'll deal with convection, followed by radiation. Your MST, conduction, convection, and radiation, 3 topics, MST. So you want to take a note down? Conduction, convection, and radiation. That is your MST topics. What you'll be tested on. Okay? Clear? Okay, so the first 3 topics are basically. Okay, so topic 1, topic 2, and topic 3. Okay, that is your MST subjects. Alright, okay. Then we have combustion and steam distribution. This one is a take-home assignment. So I will give you the assignment. You all take home and do. Want to work in groups, whatever, I don't really care. But each one is your own copy. Can okay? Then after that, steam nozzle, regenerative and gas turbine. Then 3 is EST. Okay, so that is the schedule here. Alright. Right, so if no issue, I'll continue. And basically, we'll start with the first party transfer. Okay? So now is where I start talking. Alright, so any question at time, please ask. Alright, and so we're going to start this topic. Our topic today is conduction. Okay, the first topic. Alright, so what did you learn from Thermo 1? Thermo 1, what did Dr. Q teach so far?
Gas system.
Gas? What else is it? Gas systems, closed system, open system, right? Did he tell you what's Q?
Heat.
Good. Heat. What's W?
Work.
Excellent. Okay, so heat work. Alright. Then when you have heat and work, what does it affect? You have heat going in, you got work going out, what does it affect? Internal energy. Okay, very good. Alright, so this is thermal 1 stuff. Talk about the heat going in. Okay, and obviously if you heat a syringe, what happens to the syringe? If there's air inside, this thing will move right. Because of what? Expansion. Gas expansion, right? Gas gets heated up, volume grow, right? Then it goes inside, right? So, in thermal 1, we just want to know the amount of heat going in, we want to know the amount of work going out. Okay, that's thermal 1. Right now, what we are looking at is heat transfer. We are focused only on the Q. And we are not just looking at the value of Q. We are actually looking at what? How the Q is transferred. Have you heard of these 3 words? Okay, these are the 3 modes of heat transfer right now. Alright, so you need to make sure that when you graduate from this course, you are able to identify what is unique about the 3, or when a heat transfer is occurring, you should be able to tell me, is it conduction, convection, or radiation? Okay, so these are the only 3 modes when any heat transfer to take place. Alright, so heat obviously moves from where? Higher temperature to lower temperature. This is the direction of heat flow. Always flow from hot to cold. Alright, okay? This part? Alright, so in this case here, you got a flame. It's hitting a metal rock. Okay, you hit a metal rock, obviously the heat will propagate through, am I right? Metal rock, right? Which one? Conduction. What is the key characteristic here about this conduction? Can you see it happen? Can you see that the rock is getting heated up? You only can tell from where? How can you tell if it's heated up? By? Touching it, right? You touch it, you know, right? Correct or not? If let's say the kettle, you didn't see steam coming out, will you know it's hot? No, you won't know unless you see the steam or you hear the sound, you know, that kind of thing. If not, just by visual, right? You look at the kettle outside, you can't see. Alright? So the key thing here about conduction is that, right? Okay. So key thing about conduction here is that, right? When you heat, right? How the heat propagate through? Through what? Vibration of molecules. Can you see this vibration? Cannot. Okay, you cannot see this vibration of the molecule. So this one cannot be seen. Alright? But you can know that the heat goes through. Next one, this one. Kettle, now this kettle is on the stove, so it's the olden days kettle. And it's on the stove here. Can you see the water move or not? When the thing boiling, can you see the water move? Somewhat can, right? Because if you look closely, you can see the wave, right? If it's boiling, you can see the bubble, right? Alright, so that means you actually can see it move. The key thing about, in this case here, conduction, convection or radiation? Convection, quite clear cut. Convection because you can see the fluid move. Okay, this is how we identify convection. This now, this case here, conduction, this thing is solid, liquid or gas? This thing, solid, liquid or gas? Solid. Solid, you cannot see anything move because it's molecule moving. Whereas for this one is what? Liquid. So you can see the liquid move. Am I right? So this is how you identify between the two. And the last one. The sun shine on the house. Obviously, this one. Radiation. Okay? The sun, how far away from the earth? Thousands of kilometers. Right? So when the sun shines from the sun to the earth, what's in between there? What's in between the sun and the house?
Air.
There's air on the atmosphere, right? But outside the atmosphere, what's in between?
Cool.
Huh?
Outside, that's more.
Outside there, nothing.
Cool.
Right? From the moon, even in the moon there, between the moon and the earth, there's nothing, right? Fair enough. Is there air now?
No.
Nothing. That's why the astronaut, when they fly out, they need to breathe they need the tank to breathe, right? When they're on the space station, right? Okay? So there's actually nothing there. If there's nothing there, can convection occur? No. Can conduction occur? No. Okay, because there's nothing there, the only way to transfer is from radiation. And is by what? Electromagnetic wave. Okay, so this is the last one that we will learn maybe 3-4 weeks time. Okay? Can so far? Understand? Today we will touch a bit on these two already. Okay? This one we will touch 2-3 weeks time. Alright? Okay, so with that said, this is what I talk about conduction, vibration of molecule, and then in metals you got this sea of electrons. That's why metal is a good what? Conductor. Conductor, the word keyword, you should know the word conductor. And what's opposite of conductor? Opposite of conductor is?
Insulator.
Insulator. So insulator is very hard for it to travel. Conductor is the heat very easily travel. Clear? Alright. So heat transfer vibration energy of molecule in metal is just 3 electrons. So these 3 electrons helps heat to propagate very easily through. Alright. So how to identify conduction? Okay, blah blah blah. So I say negligible displacement of body matter. So only vibration, you cannot see. Okay, negligible. Alright, now here, can you please write this down? The units for Q. Dr. Chiu's lesson, what was the units for Q? Joules, or joules, however you pronounce it. For our chapter, it's joules per second. Joules per second gives you watts. So joules per second is watts. So when you write the values for this topic Q, the value in watts. Okay, so this is what you need to make sure you take on. Okay, make sure you take on. The unit for Q in every thermal is watts. This one, I'm sorry, you need to distinguish between the two. Okay? Alright, can I continue? All clear? So this put watts. The other one is Q over area. Alright, this one is per unit area. So the don't need to bother about this. I'll talk about it later. Okay, so when you take a look at this case here, heat propagates through this. When the heat goes through this is the wall, am I right? This is the wall. So this wall here is conduction or convection? Conduction, good. When it goes through the wall, when it enters the water becomes what?
Convection.
Convection. So please understand that. What's the point I'm trying to make? What's the point I'm trying to make? That conduction can also occur together with convection. It's not going to be just conduction means conduction all the way. Okay? So be aware that you can stack conduction, convection, depending on the scenario. Alright, they can exist together. Alright? Okay, so this is some derivation. I will explain one time through. You understand good, you don't understand, not so important. Because important is not to use. So, Fourier is one guy who created this formula. Says that the rate of heat transfer is proportional to the area and the temperature gradient. Alright, so let's say we have this rod here. And this rod here, you got T1 on one end, nearer to the flame, and you got T2 on the other end, closer to the air. And then you got this Q going through here. Q is what? Heat. So the heat is probably getting through one. Alright? So obviously T1 and T2, if the heat is going through this way, which one is hotter? T1 or T2? T1. Obviously T1, right? Heat always flow from higher to lower. Okay, so always remember that. Heat always flow from higher to lower. X is what? The length of the portion you're looking at. And area is cross-sectional area. T1 here, area is what? Cross-sectional area. Okay, the area where the heat is passing through. Clear now? The area is the heat that's passing through. Okay, do you use this area? No, you use the area where the heat is passing through. Are we clear? Alright? So, if you write in mathematics, you will see it's Q proportional to A and temperature gradient. This is dt over dx. Means the temperature difference dt over the temperature, the length distance, the difference in the length dx. So, if you don't want to know, you want to look at calculus, you can ignore it. When you change the proportional sign to equal, you need to put in the k. K is a constant. Okay, which I'm going to tell you what k is later. Alright, so this is just the mathematics part. Changing this sign to equal, you need to put in this k here. The minus sign, I'll talk about it later as well. Alright? So what's the negative sign here? To show that the temperature is dropping from 1 to 2. By right, when you have a change in T in your chocolate choose method, by right, when you talk about temperature difference, you always use T1 minus T1. T2 minus T1, right? You know your formula for Thermo 1. Always T2 minus T1 means final temperature minus initial temperature. Correct? But in this case, do you use T2 minus T1? Why? Because T1 is higher. So that's why there's a negative sign here. Clear? I mean, if you don't understand, it's okay, because at the end of the day, just to make sure you know how to use the formula, you have to find it. K. This keyword here, can you write down somewhere or highlight it? Make sure you know, because you're going to get confused. You got K to deal with, later you someone got H to deal with. So what is K? It's a constant in the mathematics formula, but the meaning is thermal conductivity. Clear now? What is thermal conductivity? Constant. It's a property of a material, right? So if let's say I'm talking about alloy steel of a certain grade, okay, you will have a certain thermal conductivity. If I talk about plastic, maybe some polymer, you will have a certain conductivity. Okay? If the material don't change, will the conductivity change? Okay, that means let's say I got polystyrene, it has a K value of a certain amount. I make the polystyrene bigger, smaller, I cut the polystyrene. Does the thermal conductivity change? No, it only bothers about the material type. Are we clear? So this one is not as the material doesn't change, the thermal conductivity does not change. Are we clear? Okay, start. Next, we are dealing with the area. So this part here, A, area. Area is what? This area?
Cross section.
Must be the cross-sectional area. Clear? The area where the heat is passing through. That's why it's saying is what? The area where what? Where the heat is passing through. So this is where the heat is passing through. That's why it's in this area. Alright? Then you got your temperature difference and you got your lag. Alright, so if you write it in the okay, so this is what I'm saying. It's not very important. So if thermal conductivity is high, means it's a conductor or insulator? Conductor. Okay, higher K means easier for heat to transfer. If K is low, it's a insulator. All this part can must be crystal clear, you know. No, if you blur this part, this is the basic, I haven't come to calculation yet. Right, this is still fundamental. Okay, so high K means conductor, low K means insulator. Alright? Okay, can I continue? Yes, all done? Then alright, so moving on. Okay, so this formula is going to evolve. Okay, it's not the formula you're going to use. So this formula is going to switch to this, remove the dx out. Alright, then we integrate. That's why I tell you don't bother, you're going to do all this. And you will end up with this. Okay, now this is not the final formula for you to use yet. I just want to bring your attention here for you to understand. Okay, to look at this. So don't ever look at this part yet. This part I'll talk about later. Look at this part first. Now when you look at this equation here, this one, this one. If K goes up, what happens to my Q? If my K increases, what happens to my Q?
Increase.
Go up, right? Proportional, right? If everything constant, K go up, obviously your Q will go up. Am I right? Okay, that's why I said higher conductivity means easier for Q to go through or heat to go through. If the area become bigger, means this area become larger. What is the Q? Lower. Hey, brother. When Q go up, when A go up,
Higher.
means Q go higher lah. Hey, mathematics You understand I scared now. Right?
You also scared.
So this is A, this is K, this is delta, T over X, right? If this value on top here, any of these become high, your Q will become high, right? It says so any guy, this one go up, doesn't matter who. If your temperature difference goes bigger, obviously if these two become wider, this one become higher or this one becomes lower, then Q will become higher. Clear? Okay? Now this X, this is your X is your distance here. Okay, so the X becomes bigger. What happens? Lesser. Your Q will become lesser. Are we clear? If this one become higher. Okay, because this one become bigger, it's like 4 divided by 1 versus 4 divided by 2. Which value higher? Okay, understand? Mathematics. So this actually gives you a clue of what happens here. Alright? Okay, so when you look at this equation here, do you understand how I shift this guy down here? Do you understand how I move this K from the top to here? Do you understand this motion from here? Yes or no? Need you to show how it's done. Okay, I show because this is actually the basis of the final equation that we need to use later. Okay, so what you have here is Q equals to Ka, which is the original one. Alright, okay, see right, one. Then this one again, right? So what I do next is I multiply both sides with So So I put Ka here, right? Delta T. I multiply here with 1 over Ka. Okay, see? You see? Okay. Then down here I x, I also multiply by 1 over Ka. If I cancel these two, is it the same? Mathematically, if I cancel, because these two is actually same, right? They can cancel off, I will get this right. But right now I multiply this one in, so this Ka and this Ka cancel, right? So what do I get next? Cannot? Understand? How you switch? Cannot? If cannot, then how I memorize it? Right? Like you don't understand, you memorize it. Right, anyway, important and I'm testing here is how you use the equation. Okay, so this has to make sure you. Okay, so now come to this part. This is where the formation of the actual equation going to be. Okay, so listen. Okay, okay. This is step A. Step A is the red color. Okay, then you got step B, you got step C. So using back the same equation you have here. Okay, so this is the equation I show you here. It's obtained. When you look at step A, so this is step A. Okay, that means to ignore these two, you only focus on this. Equals to change in temperature. Which two temperature is relevant for A? T1 and T2, correct? Which is higher? T1. So T1 minus T2. This part, is clear? Okay, good. Next, your XA. Because you're looking at step A, obviously you will use XA. Divided by KA. Times by the area. Area of A, B, and C. Are they the same? Yes. Okay? So this part. Okay now? Okay. Can I? Now I ask you, if I want to find step B, because what the equation? Q1 first. QB equals to
T2 minus T3.
Good. T2 minus T3. Very good. Divided by what? XB. Because it's step B, right? Then over KB multiplied by A. All clear? Should I do it one more time for C? Tired, oh? Tired. But C what temperature? C is what temperature? C. Wait, what temperature? C. T3 minus T4 right now. So you need to remember one simple thing. A is what? The temperature is always the boundary to the layer you are concerned with. I repeat. The temperature is always what? The boundary of the layer you are concerned with. Am I clear? These words I'll repeat again now. Why am I repeating it so many times? Huh? Because it's important, it's critical to understand this concept. Because you can down there laugh, hey, this is like so obvious. I got people anyhow use temperature and layer use happen before. Because I haven't come to the hard part yet. This is too basic. That's why I already tell you the from here I'm telling you the definition of it. Alright? So this is what you have already been able to tell me. Okay? So now come to the mathematics side. I'll ignore the graph first. Okay, I will talk about start 15 later. Okay, yeah, this part here I'm going to talk about it. Look at this statement here. Okay? For steady state heat transfer, what does steady state mean? Steady state means what? Have you heard this term before? Steady state. Go steady. Steady state means does not change with time. Constant with time. Means if the condition here I say is steady state, 1 second later it still remains, 100 years later it's still the same. Everything the same, no change. Okay? So when all the conditions don't change, heat transfer to each slab is also the same. This is what? QA equals to QB equals to QC. If I ask you, in the question I ask you, what is the total heat transfer through this? Do you take QA plus QB plus QC? Yes or no? If I ask you, what's the total heat going through this? Do you take QA plus QB plus QC? No. The moment you find QA means you already know the rest. Am I right? This is same as what? You have a river flow right now. Okay, you have river flowing, water going through here. I tell you here, the volume of water going through, let's say 100 meter cube per second. Okay, there's only one inlet and one outlet. If I measure here, will it be the same? If I measure here, will it be the same? If I go around here 100, 100, 100, and I say, what is the total flow through the river? Do you take 100 plus 100 plus 100? So same concept here. Understand? You know one, you know all. Okay? It's not important, huh? So that's why I put here important, huh? Okay. So this part here is where I need to talk about it. Slide A. This is the equation, correct? Okay, so this equation here, what do I do? How do I get from here to here? Do like this, I do like that, huh? How I get from here to here? Bottom one, I shift on top, right? Understand? Huh? So I start to do the same for all. Denominator, I move up. I move past the equal sign, become multiply. This time, so I do the same for B, and the same for C. Up to this point, all clear? So what I do next is I add them up. Okay? So what do I do? I add up. So if I add up this one, I plus this one. This whole equation here, this one plus this one. So when I plus these two together, so you do it. Okay, look here. So when I plus this guy with this guy, what do I get? Correct? Is this correct? Correct, right? This one, right? Then go common, go outside. Okay, this one. Boleh ya, boleh ya. Now, what happened to here? So what do I get? T1 plus minus T2 plus T2 minus T3. So what do I have? T1 minus T3. Very good. Understand? Okay now. Because this is vital for what we're going to do. Clear?
You don't suddenly ask me.
So this is what you do. So I already demonstrate what you happen if you plus these two together. If now I plus this one also, what do you think will happen here? So here become what? Right now. Right? Three terms. Then here become what?
T4.
Because your T3 will minus 1 to T3, right? So it becomes T4. This one will become T4. Make sense? Alright? So, what you have next, lastly, you go and shift this pedal back down here. Do you see this equation here? What happened to the temperature? What did I tell you about the temperature earlier? What was the phrase I keep repeating like 3 times and then I told you it's very important?
Boundary.
The temperature is always the what?
Boundary.
The boundary of the
Issue.
layers you are concerned with, right? Now you got T1 to T4. How many layers in between?
3.
It's not simple method. 1, 2, 3, right? 3, right? How many terms are there? 3 terms. So this means what? If I want to use A and B only, means okay, let's say I want C. I only want to look at A and B. How will my equation change?
Don't have the C.
T1 minus T3, T1 minus
T3.
T3. What term is at the bottom? XA over KA times A plus SB. What, C or not? No C. Clear? Try one more time. Let's say I don't want A, I only want B and C. What temperature?
T2 minus T4.
2 and 4. So T2 minus T4. Here becomes what? Disappear. Okay? If you understand this, more or less we can almost start tutorial already. Almost. That is the key thing I needed you to understand. Alright, clear. But still got a bit more time because I haven't finished my 7:30 yet. Okay, so now, listen. This is the equation you are supposed to be very concerned with. Let me see here. Okay, so this is the equation you are supposed to be very important. Can you write this down somewhere? So today, for the tutorial, I'm going to talk about this fella. Okay, so Q equals to delta T. Of course, not 1 minus 4. What that? It will depend on the scenario. Divided by summation x over K. Okay. Okay, so up to this point, anybody got any question before I continue? Okay, alright, so I got 2 more quick stuff to talk about. Oh, you like electronics now? Don't like electronics Okay, I'm not trying to force electronics on you, but I'm just trying to show the equivalence. Alright? Current flow is I, potential difference B over R. When you look at the scenario here, whereby you have heat flow going through. Alright, this is equivalent to what? Heat flow Q, temperature difference with your potential difference, delta T, and thermal resistance R. Alright, so your R is actually what? Now here, what's your R? This is your R. Clear? So that's what we do, we just substitute. This is R. So this thing becomes this R. Clear about? So this is the basic general formula, which actually is this the main one. So this one here, R. Can you please write down what is R? In case your question asks to give you R instead of give you K. What is K first? What is R? Can you write down somewhere? So these are the few alphabets you must know one. K, thermal conductivity, property of a material. R, thermal resistance, depends on situation. K is thermal conductivity. Okay, property of material. This one is your R, thermal resistance. Okay, so these are the few things you must, these few alphabets you must know. Alright. Okay, cannot. Okay, so if you want, if you want to tell me the units of R, okay, I won't be penalizing you on this anyway if you don't write in the exam, because I think it's a bit hard to remember. K over W. Okay? Which is K is not thermal conductivity, is what? Everything constant. K is what? Kelvin and temperature. Yes, temperature over what? Okay, so conductivity K is small k, small k.
Cannot differentiate.
So that's why these units, if you don't remember, it's okay. But exam, you must put in the watts for me, the watts and the temperature. Okay, so this part, okay, okay, so we'll use that more later. Still got 5 minutes. I want to talk about slide 5. Slide 15, sorry, this one. Okay. So this is where I was talking about earlier, which I told you to ignore. This is the temperature distance graph. This is how the temperature evolves as the heat goes through. As I told you, if this is steady state, your QA, QB, and QC are the same. Good. They are the same if it's steady state. Because what? Okay? Now, if your heat goes through here, your heat goes through and the temperature drop from T1 to T2. And then when you go through B, it drops from T2 to T3. Based on looking at this graph alone, can you tell me which one the conductivity is the best? Conductivity,
D. D.
A, understand that? Why A? So conductivity is good transfer or bad transfer? Good transfer, temperature difference higher. Right? Make sense? Logical, right? Okay. So like that, you want water kettle, you want plastic kettle or metal kettle? Okay, wood. Okay, let's talk about metal pot. Metal pot. Okay? So you cook food in a metal pot, am I right? Or wok, whatever you call it. Soup or what? When the thing in there boiling, your hand is there to touch the wok or not? No, you don't dare to touch right now. Because why? Hot, right now? Metal wok is good conductor or bad conductor? Good conductor. Right? But yet the temperature at the outside is hot, right? If the temperature difference is so big, is conductor or insulator? You must understand when the temperature difference is big, let's say it's 100 degrees. If your water boiling inside the wok is 100 degrees, the wall outside will be how much? What temperature? About what? Let's say agak 90, 99, 98, right? Outside 100, right? Inside the water boiling 100 degrees, right? Then the outside of the wall, which is metal, will be about 99, 98, 97, right? So this means the temperature at the T1 and T2, is it very close or very wide? Very wide. Slight difference, right? That's the key thing. It's slight difference, right? The drop is only 3 degrees, or 2 degrees. Understand my point first? Or don't understand what I'm saying? If it's a good conductor, it should be very, very gradual line only. Because here is 90, let's say here 100, here will be 93, 98, 97. Right now. But if it's very steep, means what? Here 100, here will be what? 80, 70. So, this is insulator or conductor? Insulator. The steeper the line, the worse the conductivity. Can you write that down? Because this will be tested. The steeper, try to look for this graph. I think this graph is in your notes, Okay, write it there. Like the steeper the line, the poorer the conductivity. The more gradual the line, the better the conductivity. Need me to repeat, tell me. Yes, the steeper the line, the poorer the conductivity.
Gradual the line?
The more gradual the line, the better the conductivity. Can or not? Understand? So down here, can you tell me which one is the worst conductivity? A. The best? B. Okay, please be able to identify, okay? Alright? You might need to draw this. Alright, I'll draw one. So later is it? Okay, so with that say, that's all I have for theory. Right? So with that, let's start to do the question. Theory only. Okay. Anyone in the break? 5 minute break? Okay, so please be back by 7:35. Slab. Slab means anything that is rectangular one. Okay, so basically like this time you see all the picture I have is all rectangular piece, right? Okay, and then you got heat going through. So heating here is this surface here is a flat surface. Okay, this is called what? That's why it's called a slab. Thermal resistance for a slab. Just about. So later, as we go through, the first question is slab question. As we go through the question, we will talk about our cylinder. Cylinder is basically cylinder like that. Keep going through. Tube. Notice now the surface is what? Curve, right? So this is our cylinder. Okay, we will deal with this second question. Okay, we will do 2 questions today. One is a slab, one is a cylinder. The last one is R film. R film is basically for convection purpose. This is conduction or convection? Solid, right? Conduction. This is solid, right? Conduction. R film is used for convection. Okay, so that means let's say here is solid, here is air. Then when the heat goes through here is what? Convection. Okay, this is the last one, R film. Okay, I'll talk about it later also. So this is the stuff I never covered in the lecture. I will do the tutorial and talk to you about it. So take note, can you label as such? R slab, R cylinder. This one is conduction. This one is convection. So you remember. Alright. So take note for conduction, when it's a slab or when it's a cylinder, the equation change. But for convection, we don't care if it's a slab or cylinder. We use the same equation. Are we clear? So this one doesn't care whether it's conduction, whether is it slab or cylinder. You will use one universal formula for convection. All clear with that? Can I? Okay, good. So with that, can I wrap this? Erase that? Okay, then I want to start the equation. Here. Okay, so with that said, can you flip to page 9 of your conduction notes? And can you look at question 1? So we do easy one first. To boost morale and confidence before I start to do another harder one.
How long?
We'll see how long. We hope we can end by 9:30. We hope. Okay? No, that's 2 questions. Yeah. I cannot promise 9:30. Okay, so do question 1. All there. Please prepare about question paper, okay, or some paper. Because confirm I tell you, you sure need to draw diagram. If you don't know how to draw the diagram, you will have a lot of problems. Okay? If you cannot picture how the scenario look like, you're in trouble. Okay? So make sure you understand how the scenario look like. Okay, so the questions in your MST will look like that. Wordy one, plain English one. Okay, it's your ability to understand the question and convert it into a diagram. The diagram got marks or not? No, because the diagram is for your understanding only. If you manage to imagine in your brain and yet do the question correctly, good for you. But I can tell you, you can't. Okay, you confirm to draw one. Okay, based on statistics. Okay, so let's start. On here, an air conditioned room has a window of 2 meter high and 1.5 meter wide. So if you imagine it in 3D, this is your window. Okay, 2 meter high 1.5 meter wide, and then there's a thickness. Okay, so a thickness of 10 mm, I change to meter. Okay, and this one is 2 meter wide. This is in 3D. Okay, if you want to draw 3D. Okay, if you want to go all fancy and draw 3D. If you want to do fast one, then you just have to draw 2D cross section. Okay, so in exam I leave it to you how you want to do. Okay, and this one 2 meters. Okay, so you can't see the 1.5 meter you don't bother. Alright, clear so far? So look at this So you got 2 meter high, 1.5 meter wide, of 10 mm thick glass with thermal conductivity of 0.76. What is thermal conductivity? Simple. K. So this is what you learned before. Okay, so you should understand what's happening. This is the glass piece. The glass has this thickness, this tall, okay, this wide, with this K. If the inside and outside surface of the temperatures of the window are 25 and 30 degrees C respectively. So I'm saying that to you now that inside is 25, outside is 30, right? Like Singapore, right? So let's say I want to go from left to right. What's the temperature here?
30.
Obviously, always from high to low. So they say that the keyword here, can you highlight or put an underline? Surface temperature. This keyword here is extremely important. It's talking about the surface. Surface means surface of glass. They never say the inside air temperature is 30. How does that affect the question? If I say that it's the inside air temperature that is 30, means I need to include what? Convection. In this case, question says is what? Surface. Surface means this whole part here is what? Solids only. Only conduction. Clear enough? This is why I say the English is important. Just to highlight the surface. Who need me repeat? Okay, I repeat one time. Question says surface temperature. Surface of the glass. Means surface here. This means that when the heat transfer through is only focused, remember, the temperature is always what? The boundary of the layer you are concerned with, right? So if this is surface, the surface means the only thing you are bothered with is what? The solid glass. Correct? So that's why there's only conduction. If let's say this is 30, 30 is air instead. Air, here air, and 35 air. This means I need to include what? The air, the solid, and the air. Which means like convection, conduction, convection. Right? Convect, conduct, convect. Understand the difference now? I will deal with them in the next question. This one is supposed to boost morale, so not so difficult. Okay, so this one here, all understand the situation. So obviously, higher or lower temperature is your Q going through. Alright? Okay, so now we start doing the math. So this is the diagram you should be able to draw very simply from the question. Okay, and so once you're able to draw this diagram already, always remember in the question for conduction at least, okay, the most important equation is this equation that I showed you earlier. Still remember this equation now? You see, it was in the orange box, right? That I told you to write down. This is the most important equation. Is it given in your formula list? No, means what?
Memorize.
It's important, you know. Here is not the formula, you know. This one. Means you better remember. If not, you don't need to do the question already. Okay, so you better put a star there, take a highlighter, highlight, you have to remember this equation. But anyway, if you practice enough, this is second nature to you. Okay, so it's Q over the temperature difference over the layers concerned. As I said, the temperature is always the boundary of the layers concerned. These two are interlinked. When you pick the two temperature already, you better include all the layers that is concerned with it. Clear? Okay, if you don't include, then it's wrong. That's what I keep saying. The temperature is always the boundary of the layers concerned. So in this case, what's the temperature? 30 minus 25. Right now. Okay? So it's 30 minus 25. Should it be in Kelvin or degree C?
Kelvin.
Good. Both also can. But by right, if you need to ask yourself this question, you should be doing it in Kelvin. If you need to ask this question, means you're supposed to have done it in Kelvin. Okay, engineering calculation all in Kelvin. It's just that in this case, Kelvin and degree C same. Okay, because it's temperature difference. Alright, so if you're taking 30 minus 25, what is the R?
K.
Alright.
K over A.
X over?
A. X over A.
And this is for what? E. Right. So X what value? Do the number. What's X value?
0.01 times
0.01 meter. Okay, it's actually 10 mm. I'm converting into meter. Okay, so everything SI unit is. A, what's A? Okay. 2 times 1.5. Always remember, the area is the cross-sectional where the Q goes through. If you're not sure, you have picked this area. Some of you might even pick this area. Or Salah. Must be what? The area where the heat goes through. Clear now? Which means that the area is 2 times 1.5. So make sure you pick the correct area. Then what is K?
0.
Okay, so with this you put in your first part actually done. You get your Q. Easy or not?
No.
So easy. One equation only. Okay, so I give you 2-3 minutes. Can you please calculate this value, write it down, make sure you understand what's going on. Okay, because if you don't understand, I think we have a problem. Make sure you can key in the calculator properly. Okay, key calculator is all skill on. Okay, because I know that's how I know skill key calculator. Key also wrong one.
1140. 113.
Yeah, 113. 1140. 10. 10. 3. Yes, you get 1140. So joules per second is what? Joules per second is actually equal to what? Same joules per second is actually what? Okay, who need help? If you need help, key calculator also can tell me. Okay, then I help you. Because key calculator is very important for you.
Okay. What? I think we choose
Huh?
Tinh again.
Larger in? What is this?
Higher in concern, larger. Huh? Why you say larger?
Larger. My eyes.
Sorry.
Okay, so continue. This is 4 something. Okay, so I repeat. Watts equivalent to joules per second. Okay, this is equivalent to joules per second. Instead of writing this, write watts. Okay. Now, listen your answer when you calculate, right, is needed. Please try to give me at least 5 significant figures. Okay, at least 5 significant figures. If you are the one who have the habit of writing the whole value truncated, right, then continue the habit. But you are not in the habit to write the full value one, right? At least 5 significant figures. When you transfer, continue doing one. Okay, so the value when you transfer is similar to the solution guide that we marked. Clear, sir? Okay? So this part here is very basic. I hope you all understand what's happening here. Okay? Now, I'm going to talk about the second part. Alright, so if the window is changed to a double glazing construction, double glazing means what? 2 layers. Okay? So when you have 2 layers, usually is one glass, air, glass. Okay, so there's an air trap in the middle. So you got this guy here, and you got another guy here. Okay, and in between here is air. Okay, so here is glass, here is your glass. Alright, and so what you have here is, this is, what is the thickness? 5. So 0.005. 0.005, and the air is how much? 0.004. Okay, now, understand? Glass 5 mm, air 4 mm. So glass, air, glass. So that's basically what they say over here. Window change to double glazing construction having 2 5 mm thick glass and 4 mm negative in between, blah 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 blah. Okay, so it basically asks you to find percentage reduction, okay, in the heat transfer. Alright, heat gain. This means what? All the other properties are the same. So this means that for the glass side, the clear glass still remains. Okay? And then you have the temperatures here. This color here, the surface is still 30. Surface here is still 25. Right now. Okay here? Follow? Alright, the height is still 2 meters, so we don't bother 2 meters. Okay, I don't know. Alright, and then we go one more thing here, very important. Yes, the air is thermal conductivity. So this is where I want to talk about this thing here. 0.065. Okay, a bit messy. Sorry, I really don't like the right one. Okay. You want to write down first, then I explain something. Okay? If you are observant, a question should pop in your mind. Okay? It's a question that should occur to you if you are observant. Okay, what do you think is the question that you might have? I stated before earlier, when you have air, it's supposed to be what? convection, right? But in this case, the air, I give you what? Thermal conductivity. Means I'm asking you to assume is what? Conduction. Clear? So you must see the dilemma here. By right, air is supposed to be convection. But down here, I didn't give you the convection property. I give you K, conductivity. So what is happening here? Okay. Now, generally speaking, right, when you have air, obviously there's supposed to be motion. Am I right? So when there's motion of the air moving, then you can have convection. Make sense? Okay? Now, actually anything, any material, any liquid, both are actually happening. Conduction and convection. Any liquid, even water, even air, actually they have both happening. The surface that's very close to the solid, let's say this table, right? The layer of air that's very close to the surface of the table, the heat is actually obtained through conduction. It's only after you heat the layer, then the rest of it will start to move. That's where you have your convection. So in reality, okay, conduction and convection both occurring. It's just that conduction for fluids is negligible. Clear enough? Okay? But in this case, because your air gap is very, very small, conduction becomes the predominant mode of transfer. Okay? Understand this part? When you go out and work and you need to calculate this kind of thing, then you have to decide on your own, should it be conduction or convection. But in SP, when you take your MSP, as long as I give you K, means you do what? Conduction. If I give you another property for convection, then you assume it's convection. So we will tell you what to do. So in this case, I give you K, so you assume it's conduction. Any question? Can or not? Understand? Can? Okay. So in this case here, you see two temperature. How many layers in between? Three. Okay, go on. Sandwich 1, 2, 3. Okay. So in this case, your Q equals to delta T over summation R. Your delta T is 30 minus 25. But your R, you must have 3R. What's the first R? Starting from the left. Tell me the first R.
0.075.
Okay, wait. What's the equation for R?
X over K.
X over
K.
K, right? So what's the first X?
0.005.
Clear now? 0.005 divided by 0.76. Good. Multiply by? Good. Clear? This is your first layer. Then you follow by your second layer, which is your X air over your K air over your A. Then you can add one more time for your third layer or your second piece of glass. What's the shortcut? Here you times by 2. Okay? You can only do that if properties are totally same or identical. The moment this one becomes 6 mm instead of 5 mm, can you still times 2? Cannot. So please be observant. Those suka materials say same or times 2. The moment anything inside here change, you cannot times 2 anymore. Okay? So first and foremost, when you copy, please don't copy blindly. Make sure you understand where each point comes from. Clear enough? So understand. If you got any question now, ask. If not, feel free to calculate Q for me. Yes, because for slab, you can notice for slab, the property is that everything has the same area. You get me? So A is always the same for slab. But now you're talking about a slab scenario, it's always same in A. Okay? Okay, if you need, I give you 5 minutes to do it. If you need help, please raise your hand. Okay, remember, I don't copy value. Okay, give you time to understand the question. Please make sure you understand. For slab, I'm doing this slab, right? So, you will compare for the 5 of the
That's get wrong.
Bukan tu lagi.
What? Cannot.
Dia punya she says sikit pun.
Okay, if you all want to calculate part by part, feel free to calculate the R for me first. That means this R. This value. Calculate this value first. Don't go and squeeze everything, later you don't know what's happening. So calculate this summation R value first. Okay, do part by part. Otherwise, show mistake one. Okay, so those of you who are done, tell me the value of R. Because sometimes we do ask, what's the trouble resistance before we ask you the Q. Good. So 0.026 something. Okay, so your R, please be sure you get 0.026 something. The x means something. Okay. 7.8 is what that is. The Q. No need. Use the one again. Yeah, 189. Did you get 189?
What did I do?
189, huh?
This is what? It's under what code?
Sorry, 810. I'll continue on. Tell me, I check for
You
you.
want so different from mine, sir?
How come you tak pakai?
No lah, this one never like this. You don't see this one.
What was your answer?
Mine like
How you get 189?
I think I told you.
Wow, you do very long way and you. I do long way.
Yeah?
I do the longer way.
You do the longer way.
Like that plus it's much easier.
You get percentage.
The top one minus the bottom one.
No? Is it? Oh, you have.
Wait. Correct. Top minus bottom.
You correct kan dia just now.
Okay, 3 more minutes. Anyone need help?
Maybe their side very galak until you watch it.
Huh?
Maybe their side is so galak that they watch. Very noisy. Recording right?
Kan. Perlu sulit. Super level.
Okay, 1 more minute. Anyone issue? Okay, so I'm just going to add on the question now.
Maybe already.
Later I give you another 5 minutes to do the stuff. Okay, so I'm just going to add on the question, alright? Quick one, alright? Then I give you another 5 minutes to finish off the question, okay? So basically, you did the gist of it here. You calculated case A, part A, whereby it's single glass. You calculated case B, where there is double glass you can in between. Now, obviously, which one the Q higher? Obvious lah, right? What's the purpose of you spending money to get 2 thin glass to put with hand between for what? To prevent heat transfer lah, right? So you can see a lot of skyscraper, right? Modern buildings, all use what? Double glaze. Okay, to keep the air in. So green mount, green building, all that we deal with when you install a window, we tend to use this kind of technology so that you can keep the aircon cold air, to stop the heat from coming in. Alright, so this one we calculated, you notice there's only 189 something, what's that? So what question asks you to do is simple. He asks you to find what is the percentage reduction. Percentage reduction is always asked an answer. MST also show aspect is percentage reduction. So how to calculate percentage reduction? Okay, just remember Q of your old case, original case, minus your Q of your new case, divided by your If you want multiply by 100 equals answer. So this is why when they ask you to find percentage reduction, you don't have a choice. You must find the Q for both. Okay, so even though the question never say what is the Q, remember you read the question, he never ask you what is the Q for the new case. He just asks what's the percentage reduction. Then you have to go and settle it. You realize, oh, I need my Q. Or I cannot calculate this. When you get to calculate your percentage reduction, 23,
83.4.
23.4 or 5, 483, sorry, 83.4%. 0.4%. Around there. Okay? Can so can you calculate? I'll give you enough 5 minutes to finish off. I will start question 4 and 8:15. Okay, so 8:15, this one is a bit harder here. Alright, it's during the cylinder and there's contraction. Okay, so once we settle the question, we will remove it.
Question 4.
Okay, so those of you who want to take a look at what we are doing next, you can read question 4 because you can understand. Okay, and as you look at the question 4 before I start, okay, try to imagine how will it be drawn. Come and see how many layers are there. Alright. So it will seem very daunting because this is the first time we are doing. Alright, but you know it is good. Those of you who still have question 4 and question 1, please ask.
Huh? 4. No, you can see 4.
This is answer.
No lah, this is it.
No.
This is both sides inside.
Inside meh? Not outside meh?
Outside second. This thing, yeah, inside. This thing, one thing outside, inside. This inside,
Good.
Okay, over 50. Okay? Okay? Anyone got problem? Go on. So question 1 settle very good. Okay, so with that, I'm going to do question 4. Right? Okay, ready? Okay, so now this question gives you a lot of excess stuff. Not say excess, stuff that actually I believe you all don't understand yet. Okay, so far Dr. Chiu thought you all perfect guess, right? Air, PV equals to MRT, right? Does it deal with steam or not?
No.
No, the key thing is haven't deal with steam. You read the question here, is deal with steam. So I'm going to basically give you all the information that the steam, that you need to find on the steam table. Okay? I will not ask you to find anything on that. So I'm just going to focus on the mechanics of the question, like how to calculate conduction for a cylinder and deal with convection. I'm going to ignore all the steam stuff. Okay, the steam stuff I'll give you the value straight. Clear是吧 ？Okay, but I'll just explain the whole question in its totality, so that in case you, so that you understand what is actually given. So steam at 2 meganewton per meter square, otherwise known as 20 bar. Okay, flows through a pipe 20 meter long. So look here, there's actually a pipe. Okay, this is not the final diagram. This is just the understanding diagram. So there's a pipe, you got steam going through. This steam is actually at 20 bar. Okay, so by right, if you know about steam, you can use this value to open the steam table to find certain properties of steam, like the temperature or that. Okay, but right now I know you can't, and I don't want to waste too much time teaching this. I'll let Dr. Chu teach you. Okay, so 20 bar steam going. So 20 bar steam going, the pipe actually 20 meter long. So you can imagine the steam was generated where? From a boiler, right? So when it comes out from the boiler and is pumped into the pipe, it's basically a race against time, right? As the thing flows, what happens? Heat will be dissipated, right? And the steam from gaseous state will slowly convert to what? Liquid. You boil to get steam. You need to use the steam for some purpose, maybe for cleaning, okay, for sterilization, whatever, okay. But as it travels through the pipe, the longer the network, the more the steam will convert to water, which becomes pointless for your case, right? So obviously, when you want steam to travel through a pipe, obviously you should what? Insulate it. Minimize the heat loss as much as possible. If this is bare metal, within a few hundred meters, I think a lot become water already. And even people touch also hot. Okay, safety purpose also. So this case here, when the steam goes through, you must understand, it's basically condensing to liquid, to water. So he actually talked about the ball, we talk about that, I'll talk about it later, blah 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 blah, until you see the last line. The steam flow rate is 300 kg per hour. You see that? Okay, and then you see that it enters the pipe with dryness fraction of 0.97. Dryness fraction is how dry the steam is. The higher the number, the more dry. So obviously, if here is very dry, this is about almost 1. When you travel through, this number will get higher or lower. Okay, so X is how dry the steam is. When you go through, it's supposed to get drier or better? Better. Remember, it goes through, right? It's condensing. Losing heat, right? It's converting from hot steam to liquid water. Okay, so when it condenses, means your this value must become lesser. You see like that. Okay, because this is condensing process, right? Here is dry steam. You boil everything in, it's totally gaseous state. But when you travel through the pipe, you lose heat, am I right? So when you lose heat, it converts to water. Understand? Okay, converts to water, so you travel, it gets wetter and wetter and wetter until the X becomes lower and lower and lower. Understand the logic? Okay, so obviously, your purpose is to make sure you go and insulate it properly so that this Q is low. Then it can last longer, stay as a gas. Clear? Okay, that's the logic behind it. Okay, so I'm not going to bore you with these details because this is the logic behind it, but you don't know steam yet, so I'm not going to talk about steam so much. I'm going to focus on the whole portion that I never talked about, which is the pipe has a bore of 80 mm. Okay, so can we focus on that now? The pipe has a bore of 80 mm. So now I'm going to draw a diagram. I'm going to draw a giant diagram. So I hope that you also can draw the giant diagram on your paper. I'm going to draw like that big. So please at least use 1/3 of the paper to draw the diagram. Okay? Don't draw kitty, small one. You cannot label anything inside. Okay? So I'm going to draw 1/4 of a pipe only. Okay, so this is 1/4 of the pipe. This is the center of the pipe. Alright? So the pipe bore of 80 mm. What does bore mean? The diameter, the hole. Okay? So the pipe bore means the pipe hole. Okay, so this part hole, how much?
8.
80 mm diameter. From center to here, is it diameter? This one.
Radius.
Level, radius. So it's 0.08 divided by 2. Okay, so this is your radius. Wall thickness of 5 mm, which means that this is the hole. This is the part wall itself. This one is okay, 0.005. 5 mm. All clear with that? Okay. Thermal conductivity of 0.065 means this is your what is, oh no, 50. What is thermal conductivity symbol? K. Good, K. So this is K wall. Okay, so you have K wall already. Okay, who need more time? Shall I wait for you? Yes, I wait. Okay, so take a look at 1 quarter of the pipe. Alright, you want to draw the full pipe as a business card. You want to draw full quarter, you can hold 41. Okay, but please be important, draw big enough that you can label stuff inside. You draw tiny one, spoilers. Okay, kan? Bentar, kenapa begitu? Yeah, okay. Okay, so next is what? Cover with lagging. So lagging basically means insulation. So maybe this one is the word insulation there, because you don't know what I mean. So lagging is 50 mm thick. Okay, so from here, mm thick, with a thermal conductivity of 0.065. So it's K lag. K lag insulation. Okay, lagging is another word for insulation. Same. Okay. Any question? Okay, so I think I know layer.
What's the 150 mm?
is okay, so now here this is the new thing here. Okay, so I need you all to be alert. Okay, so this is something that I should have taught in lecture, but I didn't. I will do now. The surface transfer coefficient. Surface transfer coefficient. Can you underline this and put a symbol H? Okay, put a symbol H. Surface transfer coefficient, put a symbol H. So total today, how many alphabets you learn? How many alphabets you learn? You learn K? What's that? Huh? R, yes, R. And one more? H.
X.
K. X, yes, X also lah, but X I like opportunity. Okay, so you learn K, which is thermal conductivity, R, which is thermal resistance, and now you learn H. So I want you to be alert. Whenever you see surface transfer coefficient H, or you see flow coefficient, also H. So this H got a few names. H can be called, in this case, surface transfer coefficient, or you can call it also flow coefficient, or you can also call it heat transfer. I don't know why they give you so many names. Okay, but this is something to be alert of. All is H. And so H talk about what? H, basically when you see H, you deal with convection. Okay, so this is something I'm talking about. Okay, so this is the first time you will see R cylinder. This will be the first time you see R flow, which deals with this also. Okay, so please mark it down, take note of it. Alright, so this is some of the new thing. Okay, can I run this? Can I run? Okay. Okay. So now go back to concept understanding. I go quite slow. What's inside the pipe? Steam, right? Steam flowing through. What's outside? Air, ambient air. So obviously when the heat transfer from the steam to the air, how many convection do you see? Two. One on the inside, one on the outside. Are we clear? Okay, this is why when you read the question, they tell you what? They tell you the inside surface pipe, the heat transfer coefficient, and they also tell you the outside of the insulation surface, the coefficient. So there's two H given, right? You read and see. There's two H given. One is 50K. One is 4.5, right now. So one is for inside, one is for outside. Okay? So convection, I leave it to you how you want to draw it. I usually like to put this. Okay? I like to put you want to put what your like. Okay? So I like to put this so that I know this convection. And then because it's supposed to be working in layers, I'll just put a dotted line there so that I know this is one layer. And I know there's another layer. Okay, by right, convection operates throughout the whole thing. Okay, by right is throughout, but I just put a layer there so that I can see distinctively how many layers I have. How many layers in total I have? Simple math. 4. 1、2、3、4啊，4个你啊，对啊。Okay, so we have 4 ah, please count ah. 1, 2, 3, 4. Okay, how many is convection?
2.
2. How many is conduction?
2.
2. If your diagram you cannot see this clearly, your diagram has failed you. Simple as that. If your diagram cannot see clearly how many layers, your diagram has failed you. The point of the diagram is to show you clearly what properties are there and how you find out. So in this case, your H inside is 15,000, am I right? Okay, take note of the unit here is meter square. For K is meter, and here H outside. Any question? Okay? Okay, so inside surface, outside surface. Okay, see now, 4.5 from where? From paper, from question, so make sure you know where it is. Okay, any question? The question I'm checking with you all now is, do you understand what you draw in the diagram? That's what I'm asking. Just make sure you understand the diagram first. You don't do we're not talking about the math here. Do you understand the diagram? Okay, if you don't understand, you need to tell me, then I explain it. If not, then I can go on. Because if you don't even understand the diagram now, there's no way you can do math. How to do math if you don't understand the diagram? So, can I continue? All clear? Or need more time to think about it? Too early lah. Too early lah.
Energy.
Hey, ready lah? Can I continue?
Yes.
Who need a break? Ready lah? Okay.
You after that, then you like that.
Ambient temperature. What's the air outside? Good, 20, Now, by right, the question implies the inside temperature. Okay? But you're supposed to find from the steam table, which I am going to give you now. Okay? So you just take note of this value first. Okay, this is actually found from the steam table. If you know steam, we drop the truth on the tissue. So right now I just give you the value first. You don't bother how to find it. Okay, because I want to focus on the calculation of this, not the steam part. So can you write this down? Okay, this is given from the steam table. This one is from the steam table which Dr. Chu haven't teach you how to use it. It's from the steam table that Dr. Chu haven't teach you how to use it. So if he teach you already, then you know how to find it. So now I give you first. You don't bother to find it. Because if I'm going to teach that, then you go back at 10:30. You don't go at 10:30, right? So I give you. I give you. So you got your temperature here, you got temperature outside, okay? All clear? Start. So obviously your heat is flowing from where to where? Steam out, right? That's why as I mentioned here, condensing, all the losing heat. Okay, so going from inside to outside. So, most important equation is what? Right now? So remember I say equation cannot run on. So what are the temperatures given? 212 and 20. So you got two temperature, and remember I keep saying the temperature is always what? They are having minus more, yes, and is always the boundary of the layers concerned. So in total, how many layers? 4. 1, 2, 3, 4. From inside to outside, 1, 2, 3, 4. Clear? How many is conduction? 2. How many is convection? 2. So this is actually R film. This is R film. This is R cylinder. R cylinder. Okay, so I write it down here for you guys, for you to take note. R term, as shown in your formula list, is 1 over HA. R cylinder, as shown in your formula list, which I haven't taught earlier, 2 pi KL ln RO over RI. Okay, this is not. It's not difficult to use, it looks difficult, but it's not difficult to use. I'll cover it in a while. So please take note of these two. This is from where? Formula list. Shown in your formula list, together with the x over Ka. So because here is not slab anymore, here is cylinder, that's why you're using this. Okay? Clear the bar?
LN.
Okay? Okay, so nothing came from the air, all came from somewhere. Or some source. Okay, I now plug anything from there. Okay, the one plug, I pass you from somewhere. Okay, can I continue? Can I continue? Yes? Need more time? Can I continue? Okay, so that's why the questions I'm going to ask is the same thing again. Temperature here is 212.5 minus your 20 over summation R. So remember, I repeat again, the temperature is always the boundary of the layers concerned. So now I'm going to extract out the R to solve on its own. Follow? Okay, now anytime you don't know what I'm doing, you stop me I'm going to go step by step slowly. Okay, so I want you to follow together with me. Okay, hold my hand tightly. Solution R. Starting from hot to cold. First one is what? R what? R flow. So the equation, the first equation will be 1 over HA. Are we clear? This is inside. Labeling is of paramount importance. You label properly. Later you do very easy. You label like shit like that. Later you don't know what to put in. Clear enough? Can I continue? Plus. What's the next layer?
R cylinder.
R cylinder for the wall. Right, wall. Right, not wall. R cylinder, wall. So your next one is 1 over 2 pi KL ln RO over RI, which I'll tell you what is it later. Wall. Ln. In your calculator, on top of the lock button there. You see your calculator, there's a lock button, right? Here to it, you will see this ln button. Base 10, base E. Doesn't matter, you don't need to know the mathematics behind the understanding. You just know what this button looks like. Okay, the button is gone. Okay, fine?
So use this.
Okay, fine, we'll talk about it later, okay? May I continue? Can I? May I continue? Okay, okay, so you got the wall. What's next?
Film.
Lagging.
Same but for
Lagging.
leg, clear. So same equation but for leg. Any more? One more. Which is what? And all questions are
Film.
good. Okay, now I pause 2 minutes. When you copy this carefully, it's critical you don't make mistake here. You know when you revise the time, you know what I'm going to be writing. Okay, okay. Okay, now, coding more, you don't need to explain anything. Okay? Clear after this point. I'll go slow, you know. But I think still can hit the P, even though I go slow. Okay, any question? Okay? May I continue? Only more time. No more? Okay now? Can I continue?
Can do it.
Ain't no oxygen.
Okay, continue Okay, so now I'm going to go through the substitution of the numbers in. Okay? There will be some equation coming in that you learn in secondary school or primary school. Okay, that I think you all should forget one. So I'm going to talk about it now. Okay, so first. I'm going to put in values by putting an arrow like that. Okay, I'm going to write the value like that. Do you do this for MSP?
No.
No, you don't put arrow like that for me. You put equal sign and write the proper thing. Clear? I want you first. Don't give me this. I do this because I want to show you very well. Okay? So, 1 over H. What is H?
15,000.
15,000. Label, you label properly. You just plug the value from there to here. Easy, yeah? Okay, so 50,000. That's all you need. Alright. Next. This is what? Area. The area for the heat transfer. Listen, this whole equation here is for heat transfer. This A, when the heat is being transferred, is it through area A or area B?
No, B.
Transfer.
Heat is being transferred through area A or B?
B.
B, what is going through A? Steam, the steam flowing through A. But the heat is escaping through B. Simple logic, This is a pipe, your water is going through here, but the heat is escaping here, am I right? That's why if you touch a steam pipe, which is not insulated, you're going to burn yourself, right? Because the heat is escaping out from here. So the heat escape is from B, right now. So how to calculate? 2 pi RL or? This is what I'm saying. You learn this in primary school. This that you forget already. 2 pi RL, 2 pi R is your circumference. Then you multiply by the L is your area. Correct? How to calculate this? Pi R square or?
School.
Right? So, can you draw this and write somewhere? So that you know that these two equations still exist in this world. So this one, this future you know when to use this and when to use this. you can choose which one you want. Okay, depending on scenario. In this case, obviously, I think use R is easier because you are using everything in R. Okay, so you make use of what you have. Okay, if you are dealing with certain calculation or you dealing with diameter one, then you use D. Okay, so critical thing here, heat transfer is through B. Okay, so please focus on this one. When you're talking about the steam flow rate through here, the steam flow, you will use this one. But now it's heat flow, this one. Okay, so that's why I say very important you understand what's happening in the question. You don't understand anything, you're anyhow on top. Okay, so this is not new equation, it's old equation but never used to talk. Look like new. Okay, but it's a new old equation. Okay, can I continue? Okay, can I erase that? Apa lagi? Can I? I erase lah. I need a space. Okay, if you take photo, you know I erase already. Erase lah. Shut up. Okay. Yeah. Okay, so what's the equation here? Two pi. Clear? 2 pi R. So this is what? Inside, which means the R is supposed to be where? Inside, which is what? 0.08 divided by 2. Okay, so now here, this one is supposed to be 0.04. Clear? It's the inside physical. I know that I drew it like there's a layer here, but this is actually a virtual layer. There's no dimension to it, there's no thickness. Okay? The thickness you get from the inside R, which is this one. Okay? This one. What's the L? 20, Good. So make sure all your units are in what unit? SI unit which is what? Meter. Okay, don't mix up. Don't meter here. Okay? So this part here, first term. Any question? Okay, I'm going to go term by term. So if there's no problem here, I'll continue. So you must understand that if you do step by step, it's not the difficult. Okay, will I continue? Next, next is wall. What's the thing?
50.
50, good. What's my L? L is what? Length is what? 20 meter. Okay, good. 20 meter. Okay, so up to this point, any question? Because I want to talk about this important guy here. Okay, I want to talk about this guy here. Physical. So once you're ready, listen. So the ln is nothing. The ln is a mathematical formula. Okay, when they derived this equation at the time, they needed a ln to solve it. So I want to talk about the R row and the R right, the whole concept behind it. What does R row stand for?
Radius of the
outer radius, good. And then I obviously is inner. Focus on which layer?
Wall.
Wall layer. So there's a key part here. This is the wall layer, and it's looking at the outside radius of the wall layer and the inside radius of the wall layer. It's only focused on the wall layer. So if you take a look here, this is your wall, am I right? So this one becomes inside outside. This one?
Inside.
Are we clear? Part by part, layer by layer. If you go and confuse the whole order, you're going to have problems trying to discover this one. That's why I say, we go step by step. So when you look at wall, this is the inside, this is obviously your outside. When we look at the leg, obviously this one become your outside, this one become your inside. That's how it evolves when you move layer to layer. Can you tell me what is the value of Ri?
80.
0.0.
0.04.
0.04. Okay, see? Same, huh? Now, can you tell me how to calculate RO? How to calculate the value? How to calculate?
Plus 10 divided by 2.
0.04 plus
0.0.
clear? Okay? Now listen, if you have been using diameter here, your thickness you must multiply by 2. If you are using radius here, then you just add. Who don't understand what I said?
Again? What is it?
Okay, let's say this one I use radius now, right? Now let's say I use diameter. So this one here, remember, diameter, if let's say this diameter 0.08, right? You got one thickness here, you must also times here.
Okay.
Okay, you need that too. But you don't understand what I say, let's quit, you just focus on the Okay, so RO, you already told me is what? 0.04 plus 0.005. Okay, so I write the working out for you already. Please, when you go back and look at it, please understand why it come from. And this one is 0.04. Okay, so remember RO over RI. If you have total understanding of this is actually the same thing.
No space.
Yeah, okay. The nightmare comes when you need to key this to calculate this. Then all of you start to solve around.
Okay.
When you key calculator, please do it term by term. Okay? Don't go and try and have the whole thing inside. Sure wrong. At least some of you are. So you want to prove me wrong, you go ahead. Okay, can I continue? Okay? So next, what is the failure? Left.
0.06.
Good.
Makan
What's the
dapat.
L? The same difference. Okay? Now, quickly, what's the arrow? Working, don't need keep value, doing working. Start from the inside.
0.04 plus
0.05. 0.
Plus
0.005
plus
0.05.
good. Okay? So become 0.045. Okay? But please make sure you know where the values come from. That's not alright. Step by step. Then down here. Alright, what's the value?
0.04 plus 0.005.
Good. Okay, so I want to stress here, I think it's not difficult. It looks complicated.
Yes.
Okay, it's tedious, yes, but it's not difficult. Do slowly, do carefully, can do one. You want to hurry through, confirm salah. Done? Can I talk about the last one? Last one is what? H. Huh? 4 point? Good. What's the equation? What's the equation for it? Same, huh? 2 pi r, good. What is R?
0.055.
0 point? Yes, same, huh? Because the outer radius is to coincide with the left outer radius, huh? Okay? And then your L obviously is with this. Alright, so with that, I want you to spend now 10 minutes, 5 to 10 minutes, understand where each value come from, looking at the diagram. And then use the calculator, and you calculate for me what's the R. So this is your part A. So your part A actually asks you to find surface or lagging temperature, right? No, direct section. Change it to find R. Part A, right? Part A, right? The direct section on the steam, right? They ask you to find, right? I never don't bother about that one because you don't know steam yet. So just change it to find the thermal resistance. Change the question. Just put that, find the thermal resistance. Find the thermal resistance. Yeah, this is R. Okay, just put that, find the thermal resistance. You find the R. You want to find the thermal resistance, then you find the R. So for me, right now, give me 10 minutes to calculate this. Okay, so actually, I think we will finish before 9:30. But I need to be sure all of you can do it. But don't just go and try to calculate. Make sure you understand where the value comes from. That's the key thing I need you to understand for tonight. Make sure you understand where the value came from. Don't do blindly. Okay, if you need help with calculating, tell me. If you need help, use your calculator. Okay, please do term by term. Don't try to cut the whole thing. If you want to try it, you go and try it.
Eh, answer lah ni.
0.734. Correct, 0.11. Huh? 0.11.
It is wrong. Answer 0.0.
Got 0 something.
Huh?
I get until like that.
That one different. See my way.
You got that 0.0.
This one. Then of course only my one got 91. See one
Wait,
91.
wait, wait. Why your this one?
The other way. Well, mine is the other way.
Why you times 0.02?
Huh? What is length what?
Length is 20 meter lah, uncle.
Huh?
20 meter.
20 ah? Oh,
20 meter.
Siapa ni?
So you are very wrong. Cannot follow you.
I'm wrong. Very wrong.
Oh, sh-
See, my this one. Wait, my first one.
what now?
Length 20 meter, what you see? Change 20 meter. Huh? What's yours? First one or not?
I clear it. What if I use that one?
Not divide by 2. Take it.
Times 5 times 0.04 See?
Huh? Why yours is different, huh?
It's from inside or what?
Sir,
Ah. Oh. Okay. Yeah, correct. Yes, correct. This is correct. Correct. You write down. You want it? You write down. You write down. Write down. Write down.
It's me was right.
Yeah.
But why my laptop is negative?
Oh wait. Oh yeah, 5 It's 5.
What am I thinking? Why? You record until 1-3 only. You record until 1-3. So I was correct. It's just that I am correct. It's just that I never see the.
Your one is the old one. Usually my one also like that. Sir. 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 Sir.
So your
No, sir. Your value.
Okay, 5 more minutes to finish up this one. Hopefully you all can get it. Please practice your calculating skill. Yes, that's right.
Macam ini kan, ini overkan, lepas tu tekan.
Aku pergi letak 9 lah Anis. Betul, Anis pakai 5.
Macam gini kan, dia tak boleh. It's better macam kau buat satu-satu. So, kau buat ini dulu, 0.0 ni, satu bracket. Macam plus ni kan satu bracket. Ni 3 value plus satu bracket. Type lepas tu 20, lepas tu tutup bracket. Ni 2 pen dengan ni tak kisah. Ni pen dengan ni dia satu bracket.
Ni
Dia tak boleh. Asal lah, dia tak boleh slow confirm betul-betul. Tapi dari dia keluar lagi.
Okay, who else got problem? Those of you who got it, very good. Okay, your perseverance paid off. Really, it's perseverance. Okay, who need to check your data? Anyone? Need help?
Very good, very good.
I keep getting two.
Yeah.
I was so close.
Then,
And then, no, actually, my answer.
boleh ya? Salah.
Okay, almost time already. Who need more time? More, Can you continue? Go ahead, finish first. All done,
No, yes.
Not yet, Okay, wait another 2 minutes. Okay, I'm going to finish this session. Then I'm going to talk about one more thing about part B. Then we are done. Okay, part B, if you understand part B, means you're more or less ready for MST. First question. First question, ready for MST, one question. One question, this is one question. You still got another 2 questions, MST 3 questions. So you got 1 question done in your pocket. 30 plus. 3 lah, divide by 3 900 divided by 3 35, 30 If you like it so much, then you can try. Okay. Okay, hey, start go. Still doing. How, brother?
Yeah, still doing.
Need air.
Yeah, see what's the number you say, forget. 0.95, right? Hey, don't stress me lah.
I never stress you lah.
We only laughing. Okay, anyway, those of you who are taking this cutting tool, where is cutting tool? You should know how cutting tool, right? How cutting tool? Okay? How cutting tool? Very good, right?
How do you cutting tool?
Order.
You got the guy at top, right? You got your arm, right? Cutting tool.
Complete too long. Only complete.
Okay, and then there's part A. So I'm going to talk about part B in 5 minutes. Okay, so part B 5 minutes. I'm going to talk part B in 5 minutes. Going to come in to first. Where is done? Q lah, not Q. Okay.
Huh?
Calculate Q.
Oh,
Then
Q.
transfer into your R, right? Alright, finish off the Q lah.
Got Q.
Ah.
Thought finish.
Q so easy, right? Now talk about copy. Copy very important. Copy is the gist of the question.
Yes.
What's the Q?
Q lah.
One.
Q is what? Q lah.
Yeah, 174.
Uncle, you never divide.
Okay. Oxygen loss already. Oxygen loss
One nine two point what? I don't want that you just. You find so long, or then you don't want to use.
Okay. 0, 1,
You find the R so long, then you don't want to use the value, then you want to divide by the easier.
Mana saya Then is it what's
Find so hard, but you still don't want to use the value. Also no use.
Huh?
You find so hard, but you never use the value also fast.
Don't laugh. The above this still got some surface temperature. So you want to find the temperature.
Okay, so part B, listen what did part B ask for? Surface temperature of lagging, surface temperature. Surface temperature is where? Surface temperature is where? English must know. A, B or C? Surface temperature?
C.
C, good. Okay, can I erase this? Okay, I erase some of it. Those of you who need it, I still leave it. I think I already stopped. I need the space here.
You write, but you never use the value.
Okay, so here, I need to find the surface
C.
temperature here, right? So I need to find TC, let's say. Okay, now look here. To find TC, I still need to use that equation. Remember, this equation is the most important equation in this chapter. Always rely on this equation. If I want to find TC, this means must I know Q? If I want to find TC, my unknown is TC. Must I know Q?
Yes.
Must I know R?
Yes.
Yes. So this thing you must understand. There should be known stuff that you need to figure out from somewhere. Okay? I want to find TC. So I want to find this point here. To T will exist in this term here. Am I right? This is where T can exist only, in the delta T. So in order to put delta T, to form delta T, I can use what minus TC or TC minus what?
0.0.
I can use TC minus or I can use
T.
minus.
TC.
Understand? This means my delta T, I can use either TST minus TC or TC minus TA. Am I right? Both are valid, correct or not? Because both got TC inside. Correct or not? If I use T saturated T steam minus TC, how many layers must I? 3 layers. For R? 3 layers. So look here. If I use Q equals to TST minus TC, I must have
3.
R steam, R inside, sorry, plus R what? Wall, plus R what? Lab. Are we clear? Understand? Any question here? All must be clear, understand? Any question? Can The other way for me to find TC is I can use TC minus what?
This one software.
TA, right? If I use this, how many R's?
1.
1 R. R what?
The last one. I don't want.
R or R L. Okay? Which one is here?
Either one.
Of course, TC minus TA. Are we clear? What's the Q?
There?
This one I say must find out. Right? So now listen, I'm going to go back to what we talked about in the PowerPoint slide. This Q is what? What does this Q tell you? What's the meaning of this Q? Please tell me what you understand from this Q. What is this value telling you?
The heat.
The amount of heat lost to the firewall, right now. Remember, this is where the steam flowing through. This is the amount of heat lost to the pipe wall. So this means that the Q going up here is
Loss.
1744 something. Okay? If I'm only looking at this layer, this whole thing here is your Q going through. If I'm talking about this Q here, are they the same Q?
Yes.
Are they the same Q? Yes. Because it's steady state heat transfer. So remember I said, all the heat going through is equivalent to the heat going through one layer, is equivalent to the heat going through 2 layers, or any layer. Clear or not? So this means that the 2Q here, are they the same? Yes, they are the same. They are the same as this guy. Any question? Clear? Hungry now, So this means that when you want to find DC, use this equation. Salt water. If let's say in exam, you use the top one to find DC, can or cannot? Can is not wrong. Okay? What I'm trying to communicate to you here now is very simple. There are 2 ways to go about this problem. If let's say I need to recap this also. If I want to find TA, what are the 2 ways I can do it? If I want to find TA, what are the 2 ways I can do it?
2 ways.
Yeah, what are 2 ways? I told you TC, right? So how to find TA? 2 ways.
Same, the other way around also.
TC minus TA or
The other way around.
minus TA.
right? TA minus TA. Are we clear? Can I use, if let's say I already found TC, can I use TA minus TC?
Huh?
Cannot.
If I already found TC, before that I already found TC, can I use TA minus TC?
Can.
Yes or no?
Yes.
No.
Yes, you can. But how many layers?
2 layers.
Make sure you use the correct 2 layers. If it's TA minus TC, must be 2 conduction layer. Are we clear? You go in, that's why I say, the temperature is always what?
I got it. I got it.
The boundary of the layers concerned. The boundary of the layers concerned. If between TA and TC, the boundary of this two. If using TC and TA, this is the boundary of this layer. That's why I keep saying, the temperature is always what? The boundary of the layers concerned. Clear now? This one is key, because this one I can tell you chemistry show us.
What the?
So you need to know, even like this, even if I find TB. For TB, if I use TC minus TB and TB minus TA, is it the same effort? Is it the same amount of effort? Why? Because both also 2 layers. Understand? Because you see, for TB, right? TC minus TB, you got 1 layer here, you got 1 layer, right? You use TB minus TA, is also this layer and this layer. 2 layers here, 2 layers here. So the amount of effort is the same. Okay, but in exam, obviously try to pick the one that is easier. If you say for TC, please use TC minus TA, then you got only 1 layer. If you go and use TC minus TC, then you save effort, more effort of 3 layers, but your marks the same. So your choice but it's not wrong. Understand? Do I need to repeat this again? So with that, if you don't need me to repeat anything, can you try to do this and find for me TC? This R is this one,
The last one, right?
Yeah, the last term. If you are talking about this one, you must do the 3 term. This is why I say, don't go and hunt down all the R in one shot in your calculator. Calculate term by term. Because the moment you need it, you can use it. If you hunt down the whole R inside, you don't have the individual value, then you need to now you need to calculate again. You are using the same value. Sorry, only this one. Yeah, all the same. Is this the value you calculated on your computer for this line? Is the value you can put here?
Like here, 1.6.
This one.
This one big not right? So this one multiply this one right? This is minus,
Okay. So,
Alright, this one. Remember, you know when you have the equation, right? You got your inside, the wall, your left, and then your R outside. Outside the ear, this one. So I'm stressing again, if you don't understand what I just said, you waste your time, I can't tell you again. This is naturally important. So besides practicing on how to find TC, please go back and practice how to find TA, how to find DB. You should be able to find any interface temperature. This should be within your skill set.
okay, 52.
Okay, every single temperature, any interface temperature, you also should be able to find. Okay, those just things you need to find something here. Every single temperature should be found.
Where is it? Here. Oh, you want to hear this? you also get 82.3.
You know, but actually, honestly, final answer, we know, like, really got working way more.
Okay.
So we will know how to do that.
Okay, my brain cannot accept anything else.
Okay, so more or less, that's all I have.